Circle theorems. Angles in circles. In this lesson, we're going to explore and see what happens when we have angles in circles. Here we have a circle, and we should begin by reminding ourselves of the various parts of a circle. We know that this is the center of the circle, and we know that going around it we have the circumference. We know that as well. And we also know that a part of the circumference is called an arc. We should also remember that when we have a line going from one end to another, that's called a chord. And we should remember that when the chord passes through the center of the circle, then it's called a diameter. We know that a line from the center to a point on the circumference is called a radius. And we also know that when we have a space between two radii, then it's called a sector, the bigger one being called the major sector, and the smaller one being called the minor sector. And also we know that when we have a chord, it's going to make segments. So this is the major segment, this is the minor segment. So that's a bit of revision here, because we should know the parts of a circle before we can go into seeing what happens when we put angles inside of circles. So let's put our angles in. Here we have an angle in a circle made out of two radii. This is our angle here, and the angle is standing on an arc. This is our arc here. We can call that A, B. So our angle at the center O here is standing subtended by arc A, B. And this angle could be any size depending on how far apart on the circumference points A and B are. And of course, if they were completely opposite to each other, if A and B were completely opposite to each other, then I guess you can see that we would have a 90-degree, so a 180-degree angle. And so this angle could be any size, but in our case here, let's just give it an arbitrary value. Let's give it a value of 80 degrees. And if we have an angle at the center, the key thing I want you to focus on is that this angle is at the center of the circle, and that it's two radii coming out from the center forming this angle. So when we go on to the next page, we see that here we have two angles. We have our angle at the center again. This is the center of the circle. Let me just indicate it with a dot. And we have our 80-degree angle here again. And one of the theorems about angles in circles is that if you have an angle at the center of the circle, subtended by an arc, standing on an arc, and you have another angle standing on the same arc, standing on the same points, that is at the circumference of the circle, then this angle is going to be half the size of this angle. So if our angle at the center is 80 degrees, then our angle at the circumference will be 40 degrees. So what we're saying here is that when you have an angle in a circle, standing on an arc, subtended on an arc at the center of the circle, then another angle standing on the same arc will be half the size if that angle is touching a point on the circumference. So that's very important for us to understand, and that is the first of the circle theorems that we want to be clear about. Now when you look at this here, you see our angle here again. We said that we are taking it to be 80 degrees arbitrarily, and we understand that if this angle is at the center of the circle, then the angle at the circumference will be half the size. So this angle will be 40 degrees. And we're also saying these angles here, all of these angles are standing at the same point, standing on the same point on the circumference, subtended, standing on the same arc AE. Then we can say that angle AOE is 74 degrees. And it means that angle ABE, because it's standing on the same arc, but at the circumference, it will be half of that. So this angle here will be half of 74, which is 37 degrees. And this angle here will also be 37 degrees, Why? Because they're standing on the same points and they're at the circumference. And this one will also be 37 degrees. So we're saying that an angle at the circumference is twice the size of the angle at the circumference if they are subtended by the same arc and then the same segment of the circle. So we're saying that angles at the center of a circle and angles at the circumference of the circle subtended by the same arc in the same segment, the angle at the center will be twice the size as the angle on the circumference. So if we understand that, we should be able to answer some questions. Here are some questions which are in the learning zone. So let's answer these questions just to see whether we clearly understand what happens when you have an angle at the center of the circle and an angle at the circumference of the circle in the same segment. And be careful about that. They must be in the same segment for them to be applying the rule that I've just explained.